We've got our next speaker from Kamiwaza. Let's welcome Luke Norris, the coolest shoes at the conference.
I do get that, that's for sure. Wow, you guys are in a post-lunch like slog there, it looks like. I'll try to break up a little more energy. You sleeping in the back, I'm gonna keep yelling at you until I see you wake up. All right, a lot of it's been sort of commercial, so I'll do my best not to do a commercial for you guys and just riff on what we're seeing. Actual enterprises, I might even throw a name or two around, is actually seeing with data. So I'd say the number one thing I'm actually seeing in the market as a co-founder here at Kamiwaza, we've been rolling out actual AI, actual inferencing to Fortune 500s, government organizations. I just did the keynote about 2 weeks ago with Department of Homeland Security. I'm going to talk about that cool use case and just data. And the number one thing that everybody says is my data's either not ready for AI or I don't have enough data for AI. And over the next 10-ish minutes here, hopefully I'm going to espouse both of those, maybe be a little controversial, and maybe wake some of you guys up. All right, let's see if this thing keeps rolling. I think I'm hitting the right button. All right, so the false barrier. So we are not ready for AI, like I said. It's like the number one thing. And I wouldn't be a geek if I didn't throw out sort of a Morpheus quote. So the whole, you think that's air you're breathing type thing? Remember back in the movie where they're doing the fight in the judo? The idea there is that the data that you're probably playing with was already generated by a computer. So the fact that now you think you need humans to sit there and clean the data, move the data, prep the data, and get ready to process the data so just another computer could actually work with the data is just the craziest thing I think I've experienced. And I continue, thank you, this guy's nodding. It's all right, he already gets it, I can stop the conversation. But it literally gets to the point that you're just coming up with your own false narratives. The whole enterprise continues to find out reasons not to do this. And I'll continue to talk about this as well. There's a whole ecosystem of consultants, there's a whole ecosystem of technology providers that are there to make money based on the hours, and they want to propagate the old idea that you got to clean all your data, you got to put it into one perfect particular place, and then in that one particular perfect place, then you could process it. And it is true, there were a time when machine learning, the reductive side of AI, actually needed that. But with generative AI, it can process your data in any way, shape, or form it sits and make it usable, and you can start to reap the benefits of generative AI today. That doesn't mean it has to be structured, doesn't have to mean it has to be structured, it doesn't need to be labeled, it doesn't need to be centralized, it can be all across the enterprise, cloud, prem, and edge, and you can start to take advantage of generative AI and get extreme outcomes all the way up to the Fortune 500 and very large federal sort of use cases. All right, so jumping into one of my favorites, I don't care if it's structured or unstructured, I always point this out. And the amazing part for generative AI is it can actually take unstructured data and immediately structure it for you. What you actually see sort of behind me is two different use cases. This is a similar use case we see in every single CPG industry, from Campbell Soup, Fortune 500, to Total Return Capital Management, a multi-billion-dollar private equity firm. It's this idea that they get a lot of emails or they get data streams of pictures. And you have to actually convert those pictures typically into some sort of structured system that then the AI can pick up and run with it. One of the pictures behind me is a simple invoice. And in that simple invoice, it just literally has the pricing on one side, the volume of units, and that's about it. And then it sort of has those two sort of combined. Now the interesting part is this isn't OCR. This is a true visual model, a VLM that's actually processing it. This particular one's a Qwen 2.5 visual model. And in this, it does a couple of things. It not only recognizes the actual invoice, but it infers things from the invoice and then actually creates the JSON, the actual structured data that then starts the actual pipeline processing. One of the things it's actually inferring is in the very top, it talks about the invoice number. So it immediately takes the invoice number that's on the top and it actually then puts that into the JSON for the invoice. Further, the actual name structure is different. It actually doesn't say unit price, it just says price. But the VLM is actually smart enough to infer that and actually then put it into the JSON. So it's literally able now to take the most unstructured data sets, pictures, and actually structuralize them and actually put them into a data flow that has actionability. The second picture was actually something that Tyler, one of our engineers, and we have a booth back there, he just scribbled on the back, here's Luke's phone number, text him this and you get $1 million discount. So the other picture shows the VLM actually taking the actual writing, converting that into JSON, and actually putting that into the structured flow and system. And when you have both of these capabilities of structured data, unstructured data, pictures, data flows, Now you can just start to work this through. The point of this is literally just to show it can be the worst data. It could be data that a doctor has just scribbled and almost thrown away. As long as you have some representation of it, the AI can pick it up and start to immediately process and do anything. And keep in mind, we did not write millions and millions of lines of code to reduce this. This is a simple VLM just actually picking it up and running a very small prompt of about a paragraph to actually process these files and just move them forward. Another fun thing is the concept of, we already have all of the raw materials typically within a data center. And you don't need to get that data moved around. The prevailing concept right now, and these companies have done extremely well, and a lot of companies have done extremely well using them, the idea of the snowflakes, the idea of the data bricks, where you have to get all of your data cleansed in one particular file format, and then put that file format all in one location, that now all the apps and services can actually access it. In that perfect sort of scenario, the absolute reality is that just will never happen. It has not happened in the last 25 or 30 years. It's not going to happen in the next 25 or 30 years. Data is going to be created in so many different formats, so many different capabilities, and in so many different locations. The idea there is, how do you process it as a flow that's just moving sort of through? And how do you process it where it's actually created? The other thing I love to dive into is this concept of sort of ontologies and schemas and structures. And we'll go into that here in a minute. So you guys have all heard of RAG. It's all the buzz over the last 12 to 18 months or so. And what we're seeing the enterprise take full sort of value of data is once they can get to an agentic RAG structure. Now that's like two of the buzziest words combined together. So let me sort of try to demystify them. For us, an agent is anything that's running recursive, has access to tools, and with those access to tools, it can be kicked off through a flow or a process. That's an agent. RAG, Retrieval Augmented Generation, is just now you have an agent being kicked off through a recursive pipeline. It's running recursively all the time, and it has access to tools. Once you actually inject that agent into it, you start to open up the thematic sort of capabilities of that Retrieval Augmented Generation. And if you do that, plus inject what I'm going to go through, graph RAG, ontologies, et cetera, you now start to get a retrieval capability that the enterprise can literally unlock any particular business use case. This was a slightly smaller crew, and you guys all had mics. I'd actually challenge any of you guys to a $100 bet that you couldn't come up with a digital workflow that we haven't either already seen or could easily articulate could be done. And it's because we've been able to unlock this with our partners and understanding that sort of agentic RAG flow. Now, once again, not a commercial, but I will give you guys some cool examples here coming up in a minute. But I need to sort of just, once again, sort of backstep on this. With traditional RAG, the Retrieval Augmented Generation, the actual models are just looking up what are the similarities of the data that I need. When you can actually say, all right, I need data, I'm going to hand it to an agent, and the agent is then going to break up what tools it goes to access that data, you start to get a very, very different sort of view of the world. That view of the world allows you to start doing things like injecting graph and injecting other tools like structured data and unstructured data. But I do want to spend a sort of minute on graph, and I can't tell if it's the next slide or not, so I'll just do it from here. The idea in this flow is that there's constantly the idea of an ontology and what entity is actually requesting that data, what entity is actually needing to figure out what it is. And if you're not 100% up to speed on entity and ontology, it's what effectively has been the bane of machine learning for the last 40 or 50 years. And I have a very poor use case to sort of make it come out, but I'm going to give it to you guys. I was out with the Air Force, meeting with several colonels. Let me see, there was a colonel, a general, and a major. So the general says, son, when I say target, I mean it's the enemy that I want to target. When the colonel here says target, he's getting in the airplane and he's actually going to drop a bomb on a very individual person that he needs to take out. When the major says target, he's got to refuel the airplane, put the bombs on the airplane, and that's his target. And when the major's wife says target, it means target, and that's where she's going to go get dinner. So you got to figure out what target means from the actual person, that's the entity, and what the ontology is. And once you can have an agent break that down, Then it can reach into its tools in the vector database to actually get the more precise data from an entity and an ontological standpoint and actually inject that back in. When you combine those, retrieval plus graph plus that entity and ontology system, now you've enabled an agent to act and think much more like a human in an expertise mode. They retrieve the proper data, that proper data is inference, and literally every single workload within the enterprise unlocks immediately. And that's what we've been seeing. And that is really why we say you can get the data any way you want. As long as you can get it to us, you can go there. Now, what happens if you don't have enough data? This is a cool little example. It is our website. It's a video that we have of computer use. So one of the tools could actually be where the agent goes to a tool, which is browser use, unlocks a browser, literally goes to a website, infers all the information off the website, and then re-injects that back into the model. It can also build the data, it can store the data that way. And this truly makes it so that even if you don't have enough data, if you're missing data, it now can access a tool. And by the way, when I say a tool with MCP, with Model Context Protocol, I'm talking about hundreds, if not 10,000 plus tools. There's a whole search databases now of this all being unlocked. So it doesn't matter if your data's not clear, it doesn't matter where it's at, and it doesn't matter if you have enough, because now tools can actually go access it within the enterprise, outside the enterprise, to actually bring all that together. And I've given you the example of sort of ontologies and graphs. And what I love about this is a representation of a graph database. This is the actual pool of all the entity and the actual ontology. It's a numerical graphical representation of a graph database. Now, these models start to observe more and more of the patterns. So the more you pump through it, the more this actually builds out. This isn't what you would typically see in public use cases. These are big use cases for big enterprises. These graph databases are crunching. They're massive. They take, several 8-way sort of GPUs that are always chunking in the background. Every inference that comes through, every new file that adds, every new file that changes, it's building that ontology up and it's understanding that, running in the background, making that whole retrieval process that much better. I'm talking faster now because I'm running out of time. All right, the little commercial was, where's the data live? Once again, across cloud, prem, and edge, there already are companies like us that have found a way to actually lock it up and actually process that data. One of the key things we do, this is the commercial, is you run the private instance of the private models in multiple locations. When we process the data for RAG, we actually build a data catalog that ties the locality of that data to the local processing. Therefore, an inference request can come in across multiple locations. It actually gets redirected to the location where the data resides. It runs the RAG process there, gets the answer, and sends the answer back to where the original request came in. In this case, you're just moving kilobits, just small little tokens of data, but you could process petabytes and exabytes of data locally without having to move it, breaking data gravity. So if I take you through sort of the last steps on this, we've effectively said, you can have your data in any structure, any form, any way. You can have it actually build an ontology and an entity scheme so it knows what to do with that data. And we can retrieve, process, and run that data in any particular location. And if you mix all that together, you get this idea that an enterprise now can sort of enter the fifth industrial revolution. They can get 25% of their overall processing moved to agentic capabilities and to agentic resources. And I love this slide because this is the idea of the AI takeoff, just the graphic here, where as soon as you hit a particular point, it goes to AGI and it starts training itself, and then it becomes SGI and it just takes off and it's sort of uncontrollable. That's also the enterprise. The enterprises that are adopting this now, that are not afraid of their data, are the ones that are going to take off right now. And it only allows, if you just think about it, it's a compounding effect. If your enterprise grows 1% a month, at the end of the year, you're going to be 28% more efficient or higher growth. It's only 1%. The enterprises that are adopting this now are finding efficiencies far, far, far greater than this on a weekly basis. And if they grow weekly at 1%, it's a 41% gain. That's what allows these enterprises to take off and go faster, and anybody trying to catch up to them, even if they're a month behind, even a week behind, is a significant compounding effect. And this is why we're seeing the oldest enterprises in the world typically actually being some of the forefront in adopting AI. Last but not least, it's one of my favorite books, The Icarus Deception. There's actually a great chapter in there about Kamiwaza, not the company, but the word and what it means. And I just sort of want to throw this out to all of you. It is really easy to say, wait, let's not move forward. It's really easy to say our data's not ready and we're not really willing to do this. It is the brave people that actually move their organization forward, get those compounding effects of the organization taking off. They're going to really lead us in this fifth industrial revolution. And I challenge all of you to sort of just effectively fire your consultants, fire anybody that says your data's not ready, and start implementing this right now. And if you want, go out to our website, do a contact form, or try to hit me up on LinkedIn. I'll help you lead that. Thank you guys for the time.